In this session, we are going to see the interference and diffraction phenomenon of light. Also, many examples in our day-to-day life involving the phenomenon of interference and diffraction of light. The first diagram explains the interference of water waves. Let us consider the center of the circle as two drops falling on the surface of the pond, producing two sets of circular waves. When the two sets of waves overlap with each other, they will form an interference pattern. Interference of waves is a phenomenon that occurs when two separate sets of waves meet to produce a combined effect. In the second diagram, you have two dippers which produce a continuous sequence of waves acts as coherent sources. The coherent sources are nothing but source with same frequency, amplitude and phase difference. And we can observe here from the two source points the waves are generated and moving in the forward direction will overlap and interfere. When interference occurs, the waves either interfere constructively or destructively. When the vertical displacements of the two waves are in the same direction, the constructive interference occurs. If the amplitude of each individual wave is denoted with a letter small a, then amplitude of the combined wave is 2a. Wave 1, wave 2 superimpose on each other constructively, resulting in the constructive interference with the amplitude double the original. The second case is destructive interference. If a wave with a positive displacement meets another wave with a negative displacement of the same magnitude, then they cancel each other and the combined amplitude becomes 0. As we can see here, wave 1 with an amplitude plus a and wave 2 with an amplitude minus a superimpose on each other and the resultant amplitude is 0. Thus, the waves undergo destructive interference. Principle of superposition. In the diagram, it is seen there are two waves passing through each other. The waves overlap with each other to form a combined waveform, and this is explained through principle of superposition. The principle of superposition states that at any time the combined waveform of two or more interfering waves is given by the sum of the displacement of the individual waves at each point of the medium. Interference of light is the phenomenon that causes a reformation of the intensity of light radiations. Reformation of the intensity. It indicates the intensity of the light is being again reframed with a combination of superposition. This mainly happens due to the superposition of two or more light waves. The superposition of two or more waves occurs when the waves propagate in the same medium at the same time and meet each other at the same point. The resultant wave is a combination of all the incident waves. This means that the amplitude of the resultant wave is the algebraic sum of the amplitudes of the individual waves. Here, the representation of interference phenomenon is clearly explained through the double slit. 2 points are acting as a secondary sources from which the light is being propagating. These 2 points act as two coherent sources and the waves traveling with same phase and amplitude. Thus, when the superposition of the two waves happens, you can see here the bright and the dark fringes resulting the constructive and destructive interference. The bright fringe represents the constructive interference. The dark fringe indicates the destructive interference where the amplitude is nullified. Let us see the best examples of interference phenomenon surrounding us. First one, blue morpho butterfly. It is one of the prominent example of interference of light in real life. The blue color of such a butterfly is mainly due to interference of light and not due to natural pigmentation. The upper surface of the wings of a blue morpho butterfly is made up of nanostructures. When the light falls on the surface of the wings, the blue color out of the spectrum undergoes a constructive interference and the rest colors tend to encounter destructive interference. This is the reason why only a vibrant blue color is visible on the surface of the wings. Second example for the interference phenomenon is soap bubbles. Soap bubbles are spherical in shape and have a thin transparent layer made up of soap solution. When the white light falls on the surface of the soap bubbles and gets reflected from the top and the bottom surface of the soap bubble, only a few colors contained by the white light tend to experience constructive interference, while the rest colors undergo destructive interference of light. The colors that encounter constructive interference are visible while the rest colors get suppressed. Next example, the color patches on wet roads formed by the thin layers of oil. These color patches on wet roads are basically formed due to the phenomenon of interference of white light. The thin layer of oil deposited on the surface of the wet road is primarily responsible for the constructive and destructive interference of the colors contained by the incident white light. When the light is made to strike the surface of the road, it gets reflected by the top and the bottom surface of the oil layer and suffers constructive and destructive interference. The colors undergoing destructive interference get hindered, whereas the colors suffering constructive interference are visible to the observer. The next example in day-to-day life basing on interference phenomenon is anti-reflective coating. This anti-reflective coating present on the surface of lenses of spectacles, camera lenses is one of the prime application of interference of light in real life. The main purpose of such anti-reflective coatings is to reduce the intensity of light falling on the surface of the object. A similar interference phenomenon can also be observed on the surface of the car windows. Next example, oil on the surface of the water reflects the constructive interference colors as similar to the before example. The density of the oil is comparatively less than the water. This is the reason why the two fluids do not get mixed with each other and oil tends to float on the surface of the water. When a ray of light hits the surface of oil, it gets reflected by the top and bottom surface of the layer, which causes constructive and destructive interference, and also the multicolored visible pattern on the surface of the oil. Coming to the next phenomenon of light is diffraction. Diffraction is a bending of a light ray near an obstacle. Light behaves like waves. If light waves encounter obstacles or a slit with a small gap, waves start propagating from that gap. That gap of diffraction aperture becomes the secondary source of propagating wave. Secondary source of wave bends around the corner or obstacle, and this phenomenon of wave is called diffraction. Diffraction and interference are closely related, but they both don't have exact meaning. Diffraction is tend to be used when there are many sources of wave, and interference is used when only a few wave sources are considered. We have many examples surrounding us which deals with the application of diffraction phenomenon. The most interesting phenomenon of science of diffraction is reflecting rainbow colors. In the figure, we can see the compact disc which is reflecting rainbow colors. The compact disc also resembles the same kind of colors when viewed from different angles. Recorded data on CD is stored in microscopic pits of different length which carries information in the CD. These pits are placed in a row of same width and at equal distance. This forms a diffraction grating on the CD mirror surface. Second example you can see is the hologram. As light travels in the form of a wave, we can use two different waves of light and create a standing wave which can be photographed as a hologram. The next beautiful phenomenon of diffraction is observed in this diagram. Sun appears red during sunset. This is the phenomenon of diffraction. The reddish appearance of the sun during sunset and sunrise is due to diffraction. Sun appears red because of light gets diffracted due to the dust particles in the atmosphere. So, as you can see in the image, light from the sunset is reddish in color and trees are acting as obstacles in the path of sunlight. From the basic definition of diffraction, we can see here the bending of a light ray near an obstacle, creating the color variation. Next example is shadow of an object. Light through a shadow of an object is also a real life example of diffraction. You all have seen when there is a bright light behind an object, our object seems like a shadow, and thus this is an example of diffraction. This kind of scenes I have seen mostly in movies, especially horror ones. Well, here whichever object we are talking about is acting as an obstacle for light wave, and thus light waves bend at the edges of an object. This is the reason behind our object looks black. Light from behind gets diffracted because an object is acting as an obstacle in the path of light waves. Next example, bending of the light at the corners of the door. When you turn off your room's light in your house and lights are on in another room, you definitely have noticed light coming in your dark room. But what if we close or slightly bend the room door? The door is playing the role of an obstacle in the path of light wave, and the secondary source of light wave as described by Huygens principle. The next application of diffraction phenomenon is in spectrometer. to study the spectroscope of various elements. The spectrometer helps in analyzing the light wave of specific spectrum. Spectroscopy is used in astronomy to identify the element of which star is composed of. By measuring the wavelength of the lights from the stars with the help of diffraction grating, astronomers can tell the elements a star is composed of. Next example is X-ray diffraction. X-ray diffraction is used to identify the structure of crystalline materials. This method is based on the principle of dual wave particle nature of X-rays. So, as we all know, the X-rays is an electromagnetic wave, and this wave has a very helpful application from taking X-rays of human body to find some minor defects in bones to find the structure of a material. The main primary objective of X-ray diffraction is to find identification and characterization of a compound on the basis of their diffraction pattern. Next best example is diffraction grating. Grating is nothing but a glass plate in which several slits are being made. The formation of rainbow after a rainy day well explains us this phenomenon. The same can be performed with the help of a diffraction grating as well. You can see here the white light source is passed through the diffraction grating and resulting the spectrum of visible range. Thank you for the session.